Welcome to another episode of Code for Thought. In this and the following episode, I want to talk about Julia. Julia, the programming language that is. And if you haven't heard about it, don't worry, you're not alone. For, as one of the interviewers pointed out, when people hear about Julia, they think who, rather than what. And yet Julia is an open source language that has gained traction ever since it appeared sometime around 2012. And some serious stuff has been developed with it, for instance at NASA, as we will find out shortly. In this first part episode, I wanted to get an overview of the Julia language and community. And first I meet with Logan Kilpatrick, who is the community manager of Julia, and then with Mayeul and my colleague Mose Giordano, both practitioners and contributors to the Julia language. First, let's hear from Logan, who kindly agreed to talk to me earlier this year. Okay, Logan, hi. Thanks for your time. Let's start with introductions. Could you quickly tell listeners who you are and what you're currently doing?
As you alluded to, my name is Logan Kilpatrick. I currently serve as the community manager for the Julia programming language. I started this role back in early 2020 and going on the second year now.
Well, how did you actually get into Julia programming in the first place?
I sort of started my Julia programming journey as an intern at NASA, actually. The team that I joined just happened to use Julia. At the time, Julia was in the 0.6 release, so I actually got a chance as part of this internship to take the 0.6 code, convert it to 0.7, and ultimately end up converting all that code to the final 1.0 release. So it was sort of a serendipitous timing that I got a chance to be a part of that sort of formative years of the Julia language before the 1.0 release, and then now still be involved after that.
Well, I think talking about NASA will probably be an episode in its own right, but what exactly did you use Julia for at NASA?
The team that I was a part of at NASA and was still a part of until very recently is the part of the intelligence systems group at NASA, the NASA Ames Research Center, and that team essentially does the quote-unquote decision-making under uncertainty. So essentially using Julia and using these mathematical frameworks called POMDPs to simulate some of the things that a rover would go through on the moon or on another celestial object, essentially trying to optimize a rover's traverse to maximize the mission reward. Really interesting stuff, and it's actually a super cool Julia success story because this software that we've built over the last few years is actually going to be used on the upcoming NASA Viper mission to sort of be one of these support infrastructures for how the planning team chooses the traverse, and then also in a real-time component how they go and make decisions about what the rover should be doing during the mission, which is really cool and the first time that this sort of online decision-making tool is being used in this fashion.
That certainly sounds exciting. But Julia itself is actually not that old. I think it started sometime in 2009, if I'm not mistaken. Could you perhaps give us a little bit of a history of how Julia came about?
I'll give a really brief high-level overview of this. And there's actually some really good interviews with Jeff and with Viral and all the other folks who started the Julia language, and a much more in-depth look into this. But sort of at a really high level, 2009 came around. There was a group of individuals who were sort of thinking about programming languages and some of the setbacks or the downsides of some of the current numerical programming languages like MATLAB and such. And it ultimately transpired where Jeff, Stefan, Viral, and Alan sort of all came together initially, and they sort of knew each other from various capacities. Viral and Stefan, did their PhD together. Some of the other folks, Jeff, Viral, and Alan, all worked at Interactive Supercomputing up until 2009 together. They had sort of shared this common bond of disdain for the current state of the art, which at that time was MATLAB. And Alan sort of famously has said before that he actually had the first commercial license of MATLAB in the world was Alan's license. So he had license number one. So he was, he was a believer in MATLAB at the time, but I think there was sort of this realization that there had to be a better way and there had to be a better tool out there. And they sort of all came together and started building this. And then 2012 finally came along, and that's sort of when the language really was launched into public. And then fast forward another few years, 2015 is when Julia Computing, which is the company started by all the founders of the Julia language, sort of created that to build some commercial applications with Julia.
There is no shortage of programming languages and tools out there, of course. But in your view, how is Julia setting itself apart from other languages and tools? I mean, what's so special about it?
I have so many different answers for why someone should consider learning Julia, but I think fundamentally at a super high level, you theoretically can solve the two language problem. So, usually a developer or, you're in a traditional work environment where you want to build something, make sure that it works, and then you actually have to take that thing that you built and then bring it into some sort of production environment. And traditionally you would you want to build things fast. So you would use like Python or another higher level programming language, sort of go through this development process, make sure that the idea in your head that you have actually works. And then after that, you take the thing that you built and then you would, sort of translate it down into a lower level language that would actually work in a production capacity because of the speed. And Julia sort of solves this problem by one, being high level, and two,
Mhm.
having the speed to actually work in a production environment.
So, what would you say is the current adoption level of Julia at the moment?
This is a great question. So the Julia Computing blog post, these are sort of the folks who are much more in tune with the metrics because they sort of have a business that's sort of in line with the incentives of growing the Julia language, but doubling year over year is sort of the trend that we're seeing. And I think the
All right.
quote in the most recent Julia Computing blog post, which sort of highlighted a lot of these growth metrics, was that Julia is poised to be in probably the top 30 programming languages, and it's definitely one of the fastest growing languages out there as far as adoption goes, which is super exciting to see. And you sort of see this more fine grained in the community where you see all these new folks coming in who are really
Mm.
excited and are building super interesting projects. So it's awesome to see this sort of full circle experience for everybody.
So you mentioned academic, and I mean the reason I I didn't get into Julia itself because I'm not programming in Julia, but colleagues of mine are, and it's in the academic environment. But you already alluded to some commercial applications. I mean, how many commercial applications are out there? What's the take up there? Do
Yeah.
you happen to know that?
It's harder to know specifically what some of these commercial applications are
Yeah.
because to my understanding, a lot of the really cool things that are being built with Julia in a commercial setting, no one really wants to talk about it right now because it's sort of, the state of the art or secret or whatever it is. But there are a ton of companies. I think Amazon is a big one where I don't know specifically what they're doing, but you can look at a lot of their job postings and see that it's sort of a skill that they're looking for. And I think the folks there have sort of had the realization that it can solve a lot of their problems. Same thing with Google. I know some folks at Google who used to be super active in the Julia community, and now they've gone and they're doing interesting things with Julia over at Google, which is super awesome to see.
So let's move on a little bit to your role as community manager, because what you've described so far is actually quite a technical role. I mean, the work that you did at NASA, and I think at the moment you're working at Apple, I understand. What's it actually like to be a community manager? So for a relatively new language.
When I first got involved, I sort of got involved in a more formal capacity with the Julia language through Google Code in 2019. So I just sort of offered to mentor students and sort of help out with that process. And through that, I sort of had the opportunity to see how someone can contribute to an open source community and language without it necessarily being a technical contribution. At the end of Google Code I sort of put a lot of time into helping all these people, and the Julia language ended up mentoring 212 students, and all this awesome stuff transpired from that. But I sort of reached out to Viral and Avik and said, hey, I'm really interested in potentially helping out in some more formal capacity with something like Julia Academy, which is our platform for helping people learn Julia. And they were sort of super enthusiastic about that because the platform wasn't being utilized to its potential. Originally, I actually came on sort of just specifically to help focus on that, and then I think I don't remember the exact events, but one day, I was just chatting with Viral and he was like, oh, we have this position title actually, which is community manager, and no one has it right now. Do you want to sort of assume that role. And sort of naively, I was like, sure, I guess that's okay with me. Um, and the reality is now I think I'm sort of involved in way more than I originally anticipated I was going to be. But sort of my role in a nutshell is to just fill a lot of these logistical gaps that exist when you have this big open source community and this big project. It's
Mm.
entirely non-technical in most cases. I think there's some situations where I sort of build a technical solution for some community challenge, but a majority of things are non-technical in fashion, and I'm just sort of helping out with a lot of the administrative stuff that isn't necessarily super fun to do, but in a lot of cases is really necessary for the health of the community.
So is that role evolving? I mean, I can imagine that with the numbers doubling, the users doubling, your work increases as well. Is that right?
Yeah, it sort of always feels like there's 25 different things that I should be doing. And the reality is, I don't have time for a lot of them. So a lot of my thoughts in the last 6 months have been sort of how to leverage other people who are super enthusiastic in the community. And I'm hopeful
Mm.
that we'll be able to launch some sort of champions program or something like that, where, other folks in the community who want to get more invested in these sort of non-technical, in a lot of cases, initiatives, they can sort of come in and help out. And there's just so many opportunities to have an impact. And the reality is I don't have enough time in the day to be the person to drive that change and have that impact for all of these initiatives that would help the community out. So I'm always trying to
Yeah.
find people to help me with that.
What's your plan for 2021?
Yeah, so 2021 will have an in-person JuliaCon, being led by Jane and Vic again, who sort of led it last year as well as co-chairs of the conference, and they did an incredible job as well as the rest of the JuliaCon committee. So really exciting. So I think 2019 JuliaCon, we had something, and I might mess these numbers up, but I think it was somewhere around 10,000 unique viewers with all the content that we put out. 2020 JuliaCon was somewhere around 28,000 people. And hopefully sort of the advantageous goal is to do another leap here and get somewhere closer to 50,000, 100,000 people engaged with JuliaCon this year, in a totally online fashion. And we're looking into ways to sort of make it more engaging. So yeah, it's super exciting. Hopefully 2021 JuliaCon, I have no doubts, will be a smashing success.
That's a nice segue into my final question, which is where do you think the Julia community is going and Julia itself beyond 2021, beyond this year?
I think that the really nice part, this is like one of the best perks about having the role that I have right now, is that I genuinely think that the Julia community does so many awesome things organically that we are no doubt on the right path to a very fruitful 2021 and beyond, which is super exciting for me. And there's really not much that we don't do well. I think just generally the community is so positive and everybody's so helpful, and it makes it a lot of fun. I think where I think we can improve a little bit and fix some things is just in these like general accessibility ideas, like making it so that the documentation is accessible to more people, building out more resources for learning Julia, and sort of solving a few of these other smaller pain points in the community. If we can solve those in a really positive way, then I have no doubt that the Julia language will be one of the pivotal languages in the ecosystem in the next year or two.
Finally, I said the final question, but actually, there's just one that pops to mind. If I were to start in Julia, where would I start? I mean, how can I get into it?
Yeah, julialang.org/learning. There's a learning tab, and we sort of have things broken down into a bunch of different learning modes. Like if you want to learn through a textbook because that's how you've learned every other programming language, great, we have that for you. If you want to get one-on-one mentoring through somebody who knows Julia, we have that for you through exorcism.io and all of the folks who volunteer as mentors on that platform. And if you're sort of more inclined to potentially a traditional university learning platform, we have that through Julia Academy and through some of these other courses. Like, for example, there's an MIT course that just wrapped up where, we had the opportunity to have a bunch of YouTubers actually build a lot of content for MIT and in Julia. And it was a super super big success, millions of views on that. So there's sort of all these different learning modes that someone can take advantage of. And I encourage you all to go to julialang.org/learning and check all those out and find what works best for you.
Next, let's hear from Mayeul and Mose. Both have been advocates of the Julia language and also been contributing to the development of the language. I wanted to get their perspective of what the benefits and challenges are. Let's do their introductions first, starting with Mayeul.
I'm a research software engineer by trade. I've been in this trade for quite a while now. Did my PhD in Paris in condensed matter physics, moved to a national lab in Golden, Colorado, where I did some computational material science, and then moved back to the UK. I joined the UCL group there as an RSC. Then I've been moving back and forth between RSC and the private sector, and most recently I'm now part of Kagenova, which is a startup that does AI and virtual reality.
Excellent, thank you. Mose.
Hi, I am a research software engineer at the UCL. I did a PhD in physics in Italy. After that, I did a postdoc for 1 year, again in physics. I've worked in this industry for a few months before moving to the UCL RSC group.
This episode is about just general overview of Julia and the Julia programming language. And what I would like to start with is to see how you both got involved with programming in the Julia language. How did that come about?
I got involved with it when a blog post came out about this new language in something like 2012 to 2013. And this new language supposedly was both Python and C at the same time, in the sense that it's easy to use and yet performant. I started looking at it at that point. I haven't managed to actually use it in anger, so in a job outside of forcing a few people in some few cases, but basically to actually have a real project that wasn't just me piggybacking on some other project. But ever since, I've kept up with the language, looked at every other package that come out with it.
So I also saw the blog post that advertised Julia in 2012, I think it was, but I didn't pay much attention back then. And then I think it was around 2015, end of 2015, I read a research paper that was using Julia to do some high-performance computation in astrophysics. And I said, well, maybe I should try it out. And then after a few months, I got the occasion to use it for my PhD. So I wrote my first code in Julia for some research for the PhD.
Since Julia is relatively new, could you summarize to somebody who's not heard about it what Julia is and what the benefits of using Julia is in comparison to, say, other programming languages? I think, Mayeul, you mentioned Python, for instance.
There's several benefits, I think. The one that are advertised are mostly the fact that it's a modern language, so it's easy to use. You don't have to worry about memory. It's garbage collected. The syntax is reminiscent of MATLAB, and which makes it fairly easy for most people to grasp. But on the other hand, it's also just about as fast as C, depending on your use case. It's a language that is efficient for the programmer to use in terms of his or her own time, but it's also efficient for the computer. That's great, but actually what I find more interesting in Julia is that because of its type system and because of how it uses multiple dispatch, it really allows people serendipitous collaborations between people who had no idea they were going to collaborate, or between projects that had no idea they were going to collaborate. So for instance, there is a state-of-the-art ecosystem for solving differential equations. And then, there's also this package about adding units as a type, so physical units. So for instance, you can say that this array is in joules and this array is in electron volts. And it turns out you can use those two together. So you can solve your differential equations and define the parameters of your differential equations using physical units. There's also a package that does symbolic maths. Turns out you can actually plug that directly into the differential equations and figure out what those formulas are used in the differential equations. and the integrators and so on. Those packages were not developed to work together, but they do. And that, I think, is what's most exciting for research software engineering and for research, because we're always piggybacking on other people's work. But Julia is extraordinarily efficient at having people piggyback on each other, on each other's projects.
Yeah, in the Julia community, we have the saying that came for the speed and then stay for the features, because usually the first thing that you heard about Julia is that it's super fast, as fast as C. But then you realize that there is much more than just speed. There are like features like the multiple dispatch that Mayeul mentioned, the type system, which is very smart and very powerful. So if you put all these features on top of the speed, you get a very powerful language that lets you do more and more work. Especially, as Mayeul said, you can easily collaborate with other researchers, because you write a package that you don't expect to work with something else, and then it magically does.
You're both physicists, so you try to solve engineering problems or software problems from a particular perspective. What would you say are the typical engineering problems that Julia helps you to solve? Is that just exclusively due to physics and mathematical issues?
So there's two things to that question. There's one is what a community already exists and so has created the tools that you need to solve that, and whether Julia itself could potentially solve a given problem. So Julia is a general language. It could be used for most everything. That said, it does have a bend for numerical stuff. The most of the community is inside Julia or sub-communities doing physics or math or data science. So it's mostly about crunching numbers to some degree. I don't know why it doesn't get that much interest, but the way that you can call external programs in Julia is really good. The interface for accessing external program is really good, really simple to use and extensive. So basically you can replace all your Bash scripts with Julia.
Could you give us an example? I mean, I know it's a little bit difficult to do this voice only, but could you give an example of what that might look like?
Basically, you have some form of quotation mark that will run an external command, plus some piping interface so that you can pipe different commands together. And then you can get the results back.
This is platform independent, so it doesn't use the shell that is currently used on the current system, but Julia does its own parsing of the command that you're going to run. So you can really write scripts that are platform independent, so they will work equally well on Windows, Linux, or macOS.
So you mentioned that it's cross-platform, but what kind of computing environment are we actually talking about? We're talking about data crunching, AI, etc. So, okay, you can run it on a single computer. Could you run it on high-performance computing environments as well?
So you write your code for a single node with a standard array, but you could easily then say, okay, actually, I don't want a standard array. I want to use a different type of array that works with GPUs, and all of a sudden your code works on GPUs. Or you could say, actually, I don't want to use a standard array. I want to use the shared array. So now you're using OpenMP-like characteristics, parallelization. Most always, you will not have to change your code. The only change is you're going to call this function with a different kind of array. That's it. So it can be used in all those settings. It can be used on a single node. It can be used on GPUs. It can be used on a supercomputer. I believe it can also be used on, somebody got it working on a phone somewhere. The one drawback is that it does have a fairly large runtime. This may change in future versions.
So the footprint is rather large then.
Yeah. You can actually compile your code to a binary. I think the hello world I saw somewhere, I don't know if it was a joke, it was a gigabyte. That's not very impressive. This is something that people expect to work on. The people who are developing the language expect to work on, I think. This is one of the things that make it interesting about Julia is that it's an open source language. So you can go to GitHub, go to the Julia repository, look at the issues, and people are talking about how to create the language, what are the design goals, the constraints and everything. So for RSCs like myself, this is really interesting because you get to see what goes into creating a language.
This is actually one of the reasons why I stuck with using Julia, because I was interested in contributing myself to to development of the Julia language itself. I started when Julia was around version 0.4, I think. So it's really something that makes you an active contributor. And another nice feature of Julia is that most of Julia code, of the code of the Julia language, is written in Julia itself. So if you know how to code in Julia, you know also how to contribute to Julia itself. You don't need for most of the time. Only the inner parts of the Julia compiler are written in C++ because they talk with LLVM.
From your perspective, how many people are using it? Is there still some convincing to do? Is it very widespread? Is it growing?
Not as widespread as I'd like, but it is growing. It's I think it's some Stack Overflow index where they were saying Julia is the most likely language to become the part of the top 10. It's still difficult to get people on board because it's new. However, there's more and more students or younger researchers who are more open to using different tools. It's definitely a growing community, and there are growing pains as it tries to establish itself within an existing community.
Gauging the number of users is the $1 million question, because it's very hard to get numbers. However, there are some indications that the use of Julia is growing. For example, Julia Computing a few days ago published some statistics about for example, the downloads of Julia, which increased by 87% in total, just over the 2020 year, last year. So just in 1 year, it almost doubled the number of downloads of the language, which is quite impressive. Because maybe until 2 or 3 years ago, if you mention Julia, they would say, maybe they would say, who is Julia?
Well, that was my reaction, basically, because, I started as an RSE just recently, sort of about a year ago, and I haven't heard it. Obviously, there's some convincing to do to get people on board with Julia. So a lot of people still don't know. Some of them are conservative and say, I'd rather use a language that is tried and tested, and Julia, for me, is too new. How would you actually influence people in your environment? How did you influence people in your environment to adopt Julia, or to at least be open-minded about it?
I think the question is, what is the time to publication when you start a project, right? This is how research works. So maybe your team knows this language, this C++ or Fortran very well, but the development time in those languages can be 5 or 10-fold larger, especially Fortran. So whatever takes, 6 months in C++ or Fortran would take a month or 2 in Julia.
That's a bold claim.
That's a bold claim, yes. But the point is, it really, and it does depend on the project. But those projects that are really about number crunching are generally don't make use of an ecosystem very well. If you're using Fortran or C++, interfacing with other libraries is painful. Dependency hell is a real hell that we all have to live with, and that goes away with Julia. So that means you're much more likely to use other people's code, which means that the work that PhD student or RSC or somebody has to do to get to the time of publication is much smaller. There's also the fact that the language itself is a hell of a lot easier to use. Hence, you're saving time there, and that's why I think that claim might sound bold, but it's not a fantasy.
Okay.
Maybe your perfect C++ or Fortran program is going to run faster than Julia, but it's only going to run after 6 months. I think my main point is the time to publication is a lot shorter, and the time to the next publication is also shorter because it's a more modern language. It's easier to interact with. Hence, the next student, it will be a lot easier for her to pick up the code and move it further.
Yeah, if I can add something to the time for development, since Julia is at the same time easy to use and fast, you can write both the prototype and the final production version of your code in the same language. So this is quite the opposite on what often happens in research when you write, for example, a prototype in a simple language like Python or Dar, and then you rewrite the code for performance in C++, for example. That's a huge waste of time because you literally have to rewrite something that it was working already before. And that's why usually people say that Julia solves the two-language problem. And also, even if you are very attached to your old code written in Python or C++, you can easily call libraries in other languages. So you don't have to ditch whatever you have done before, but you can gradually move into Julia.
I hope this episode has given you a flavour of the Julia language, what it is used for and why. If you're interested, there are a few links on the podcast website and I encourage you to check them out. In the next episode, I want to dive into more details and talk to Jarvis and Lyndon about some of the Julia programs and code they wrote. I hope you tune in for that as well. And with this, goodbye.